In this video, I'll show some examples by integrating by parts. And here we're just going to use indefinite integrals. Of course, it would be very easy just to insert limits of integration and make these definite. So suppose we have the integral of x times e to the x dx. Now we have no elementary way of doing this, but this lends itself very well to integration by parts. And in general, if we have a polynomial times either an exponential or a trig or a logarithmic function, that is an ideal situation for integration by parts. And so what we're going to do is choose u equals the polynomial part. Here u equals x and v prime equals e to the x. Well, the derivative of u prime would just be 1. And the integral of v would just be e to the x. And so we'll get u times v, that would be x times e to the x, minus the integral of u prime, which is 1, times v e to the x dx. Well, that integral is a very easy one to evaluate. That's just e to the x. And what we get is x e to the x minus e to the x plus c. And it's worthwhile taking a derivative of this and verifying to yourself that the derivative is x times e to the x. Another example where integration by parts is very successful is integrating just the natural log of x. The perceptive student will notice this is really the last elementary function that we have not yet integrated, and we want to talk about how to integrate this. Well, we don't have many choices here, so what we're going to do, we're going to choose u equals just log x, and we're just going to say v prime equals 1, because obviously you could have a factor of 1. Well, then u prime is going to be the derivative of log x, which is 1 over x. V, the integral of 1, is just x. And so now what we have is u times v, that's x log x, minus v, which is x, times u prime, which is 1 over x dx. Well, that integral, that just becomes the x and the 1 over x cancel. It just becomes the integral of dx. And so that is very simply just minus x. And so the antiderivative of log x is x log x minus x plus c. And again, it's worthwhile taking a derivative of this antiderivative to verify that the derivative is in fact log x.